Welcome back. So, we started understanding the two period model, and in two period model we derived the lifetime budget constraint in the last session, and we will have the similar reference here. It will remain the same, not much change. We will be having the same references. So, Eric Sims is going to be the major reference and the Williamson. So, you can refer these two book apart from the Sanjay Kechuk that we have. So, this particular textbook is so we examined this part. Now, we will be further. So, we have derived this part. What was the simple step that we derived the first period, then we derived the current period, then we derived the future period. So, one period, second period we derived the saving, because in the first period he is saving some amount, and then we superimpose this into the budget constraint of this. So, here if we can simply go for substitute this here in the current period, then you can have the Ct plus Ct plus 1 minus Yt plus 1 plus Tt plus 1 upon 1 plus Rt, which is equivalent to Yt plus Tt, and finally, we are able to derive this part, which is the lifetime budget constraint. So, this is how it looks like. Simplified lifetime budget constraint is this, right. Now, we have to understand certain dynamics. What are those dynamics? One is that when we are having a such type of scenarios, which is having the suppose y transpose t and minus t transpose t is the future period. So, here you have the future consumption, this side you have the current consumption, and this is the budget line of the representative consumer. So, endowment in the current period is this WE, and endowment in the future period. So, income endowment, wealth endowment in the future period is WE multiplied by 1 plus R. Here instead of t plus 1, we are just focusing on transpose. So, y transpose t transpose is equivalent to Yt plus 1 and Tt plus 1, and here y minus t. Here you have to note two things. Here this particular bracket shows that during this from this to this B to E, the representative consumer is a lender, and from E to A, the representative consumer is borrower. When do we say that? So, here we are defining the boundary of this representative consumer, that this representative consumer is having y transpose minus t transpose, and then here it is y minus t. Now, if we go for, suppose if I am saying that this representative consumer is here, so consumption is this much, which means that the future consumption is this much and the current consumption this much, which means that this representative consumer will have to go for extra amount of borrowing. So, which means that if I am drawing a line here like this, then this is leading to what which is called the borrower. Borrower means in the sense that here you have the future period consumption increasing. So, here it becomes, then here we have the current period. So, in the current period here it is the lender, and once it is lender, then why it is lender? Because if I am saying that the current period consumption is this much and future period consumption this much, means that this is the income of the representative consumer, and this representative consumer, if he is going to consume till here, it means that this much he is saving, and this he can transform into the future period consumption. So, the amount that goes to the future period, suppose this much. So, this is the saving that he has, and he can go for lending it. So, this amount can go for, and then it will become 1 plus RTST. Let me give you one more example. This is important to understand. When I am saying that the consumer is a lender and here it is borrower, this is the income threshold that we are defining for this representative agent. The moment I say that it goes beyond this, it comes this side, then here it becomes the extra borrowing for the, because this is the boundary line for the consumption. So, if the moment it moves this side, it is a borrowing zone. The moment he moves this side, it is the lending zone. How we are moving this side? If suppose this representative consumer is consuming this much in the future period, in current period is consuming this much, which means this much amount of current income is saved, which can be transferred through the future period. So, this becomes really important to understand. Second thing, if you want to take in calculate the slope of this, so you can simply go for Ct plus 1 upon Ct is it becomes minus 1 plus R. It is easier. So, slope of this is minus 1 plus R. This is what we try to define. So, this is the budget constraint that we have. So, I hope the lender and borrower case makes easier to understand. Then here we have the indifference curve. So, I think it remains same that we have done in the one period model, that there also we have assumed the same thing, that here you have the future consumption and here you have the current consumption. It is having the well defined convex, which means that more is better, that criteria. The only thing that you have to keep in mind the properties of the indifference curve, that it will not have the intersect, two indifference curve will not intersect. On the indifference curve, wherever you are, the utility remains same, not much change. So, those conditions will satisfy, and the Bayes constraint variable, it will tangent to the indifference curve, that will be the point at which he or she is having the optimal level of utility. So, in terms of current and future consumption. So, those things are same here, not much change. In preference also, the only thing is that we have to make sure that we have to arrive at the point where he is indifferent about choosing current and future period consumption. So, that is the trick that we will be using it here. Now, overall lifetime utility. So, here we will be working on the utility function. Now, unlike the one period model where we had CL, here we are having two period model. So, here we are going to utilize. So, here we have u is equal to u c t is equal to beta u c t plus 1. Now, more or less it remains same here. So, we have to maximize this with respect to c t plus 1. So, we can write here max c t comma c t plus 1. Here you have a u c t plus beta u c t plus 1, and this is what we have the behavioral coefficient, which means that how much this particular agent is going to give more weightage to the future than the current. If the beta is higher, more weightage to the future; if beta is lower, less weightage to the future. So, this beta, the unknown parameter, is going to decide about the preference of current to future period future to current period. So, here it measures. So, it is also the measure, you can say in I would say in different way also. So, here it is called discount factor, it lies between 0 to 1. It measures how the household values current utility relative to future utility, which means that how this particular representative agent is going to decide about whether he has to save more in the current period for the future, or he should be utilizing all his income in the current period itself. We assume that beta must be less than 1, because if it is 1, then there is no point in investigating the equal to examine. So, this is how we try to put this weight. Now, we have already gone for lifetime Bayes constraints. In lifetime Bayes constraint, here we have C t plus 1 upon 1 plus R t is equal to y t minus T t y t plus 1. So, here y t plus 1 minus T t plus 1 upon 1 plus R t. So, now we can go for the optimization condition. In case of two period model, the optimization condition has lot of meaning, and optimization condition has meaning in the sense that here it goes for deciding about how many periods this representative agent has to, so whether he has to at what, so in what situations this representative consumer has to can be indifferent about the current and future period consumption. So, for that we have max C t plus 1 u c t plus beta u c t plus 1. Here we are writing subject to the Bayes constraint that we have is C t plus 1 upon 1 plus R t is equal to y t plus y t plus 1 upon 1 plus R t. So, here you can go by using both the methods, either you can go by Lagrange multiplier or you go by method of substitution, which means that you solve for C t plus 1 and then substitute C t with respect to all in C t terms, and then you go for the direct differentiation, or you can go apply for Lagrange multiplier and go for partial differentiation. So, it is all possible here. So, let us work it out. So, here I go by the method of substitution. So, here what we do is that we solve for C t plus 1 here from this particular equation, and then we try to substitute. So, if you solve for C t plus 1, this is what we are going to get. So, here C t plus 1, it becomes 1 plus R t y t minus C t plus y t plus 1, which means that if I am going to substitute, if I am going to solve C t plus 1 here, this is the expression that we get. I substitute this C t plus 1 in this, and this is how we get. And to find the optimum, I go for differentiation. So, I write here du upon d C t. So, the first order condition of this will be this, the marginal utility of the current period consumption minus beta plus the marginal condition that we have So, here it becomes since we are differentiating with respect to C t. So, this becomes -1. So, here you have minus, and this is the expression that we get after differentiation. Since C t plus 1 is equal to 1 plus R t, Y t plus C t and Y t plus C t plus 1. So, this is the expression that we get for C t plus 1 if you are going to solve from here. So, C t plus 1 we are having the same expression like this, we are also getting it here, which means that I can now write it down. Marginal utility of C t plus C t is equal to beta u transpose C t plus 1 into 1 plus R t, because why C t plus 1? Because we have the same expression here. So, here it becomes, so here C t plus 1 I am just substituting it here. So, if I substitute this here, then it becomes beta u transpose 1 plus R t, and this is the expression for C t plus 1. So, this I write it here. So, here we have, what is the condition that we are getting? Here we are getting the condition of marginal utility of current period consumption is equal to beta times the marginal utility of future consumption, and it is also multiplied by the rate of return that he is going to get when he is saving some amount of income in the current period, which he is going to get in the future period. So, this is multiplied. So, the factor that it is multiplied, that we have 1 plus R t here. It is coming from the representative agent, that if you remember here I had shown you that he is going to get some amount of income in the future period. So, this is the 1 plus R t, here it is coming 1 plus R t, because whatever amount of money that he is going to save in the current period, he is going to get 1 plus R t in future. So, this is here we have 1 plus R t. So, this is how it looks like. Alright. So, here we have the marginal utility of current period consumption is equal to beta times multiplied by beta times 1 plus R t times the marginal utility of future consumption. Now, what is this meaning? So, this particular condition has lot of applications in macroeconomics, and lot of time when you try and understand when you work with the very advanced macroeconomic models, for example, the dynamic general equilibrium models, and then you try to understand from the stochastic perspective. So, you try to introduce the stochasticness of the model, then it becomes dynamic stochastic general equilibrium model. In macroeconomics it is very common. So, DSG models are quite popular these days. These models help you understand with a similar kind of setup and try to get the inference about the macroeconomic picture by introducing different agents. So, this particular course is helpful to understand that kind of dimension of DSG. So, it will give you the brief idea about, in a very, I would say, very mature idea about the DSG model, and then you can further use such formulations in your DSG modeling formulation. So, unlike macroeconometric models where you have lot of applications of simultaneous equation models, where we try to work with the large set of simultaneous equation we identify and then we try to estimate the model. People have gone for understanding the dynamic stochastic general equilibrium model, where they theoretically build the different agents and try to define in theoretical context, and then they try to calibrate that with certain formulations. So, that kind of understanding has become quite a mainstream macroeconomics these days. So, such type of micro foundations are important to understand those dimensions. Otherwise, IS and ALM framework or even the basic macroeconomics, though it gives you the feel about the functioning of the macroeconomic indicators, but in the context of the recent developments, if you try to see, then you will not have idea that where are we heading. So, these days a lot of theoretical aspects about the macroeconomics are being examined, and in that context this particular textbook, this particular course is going to be helpful. So, here the marginal utility of current consumption is equal to beta. Here you have the marginal utility of future consumption multiplied by this. This we call it that if it means that the marginal utility of current consumption is equal to marginal utility of future consumption, which means that future consumption multiplied by the rate of interest that you have, which means that your future consumption, if you are, how much you are saving, whatever you are consuming today. So, which means that marginal means whatever extra that you are consuming today, it is equivalent to saving that extra unit in future. So, which means that now at this level the consumer should be indifferent that how much he has to save subject to this behavioral coefficient or discounting factor this we have. It means that if you save a little extra today, right, this is the marginal utility, this will leave you with 1 plus RT extra unit of goods tomorrow, because this is the reward that you have for the future consumption, which will yield which is going to yield you extra utility which is having this part, which means that if you are having 100 rupees, if you are going to save some 40 rupees today, you are going to get 40 into 1 plus R amount in future. So, if you have planned to save some amount, so this amount will be transferred to future. So, it is up to you, either you consume today or the future. If you are consuming it today, it will be simply the marginal utility of current consumption, but if you are saving that amount, then it is equivalent. So, this particular part it becomes really important to understand that marginal utility of current consumption, it is equivalent to the marginal utility of future consumption about multiplied by the behavioral coefficient beta and the rate of interest that you are, so earnings, interest earnings that you are going to have. In the dynamic optimization context, this particular equation, it is called the Euler condition. So, Euler condition it is having a lot of meaning in macroeconomics and even in the field of dynamic optimization, and here this equality has a lot of meaning. So, this equality can be interpreted in a different way also. So, finally, marginal utility from consuming extra today must be equal to the marginal utility of saving and extra today, which means that if you are saving, then you are going to get this much amount in future, which also means that if I am going to work out further, so what will be? So, if I am going to derive the marginal rate of substitution, which is the ratio of marginal utility of current to future. So, how does it look like? So, if it is going to be, then here marginal utility of current consumption, here bracket I missed. So, here the marginal utility of current consumption, it is the ratio of beta times the marginal utility of future consumption, here again we should have the bracket, and then this is equivalent to 1 plus RT, which means that the ratio of current to future consumption, it is dependent upon or it is equivalent to the future interest earnings that you have. So, reward that you are going to get, but keep in mind that we are talking about consumption, but consumption as such that we study in macroeconomics, this is not this part, this is the micro foundation. So, here from here we cannot say that this is the consumption function, because this is not the consumption function. The consumption function is equivalent to when you have the consumption is dependent upon current, future income and rate of interest. So, that part will be taking up later, but here this particular condition helps us understand the 2 period scenario in a better way, that given the current and future income, how much this representative agent will have the opportunity to either consume 1 unit extra today, or it should be equivalent to what he saves that unit in the today, so that he gets extra 1 plus RT on that unit in future. So, that dimension you have to think in that dimension in terms of preference, not in terms of the consumption function that we normally assume in case of consumption theories. So, if you think about the slope, so this is how it looks like, right. So, here we have the current period consumption, and here you have the future period, here you have the current and here you have the future. So, here it mentions about both. Now, let us have one example, and I think this will clear your understanding about, and you should also have the feel about this model. So, to have the feel about this model, we are going to work out this particular example, and then we will have further scenarios to deal with, and that will further strengthen your understanding of this topic. So, here suppose we have the 2 period economy model, a 2 period representative agent wants to maximize the value of the utility defined over consumption in 2 periods. So, he has CT and CT plus 1. Utility is represented by UCT plus beta UCT plus 1, and UC is equal to log C. The consumer receives YT and YT plus 1 respectively. The agent can freely borrow and lend in financial market at the rate of interest R. So, this is what we have the R. So, we do not have any kind of frictions in the financial market, no asymmetry at all. the rate of interest same means whatever amount of money that I am going to keep in the bank, it is offering me 4% rate of interest. If I am going to borrow from the bank, it is still offering me the same rate of interest. So, there is symmetry in the credit market and there is no asymmetry. Normally, it is the case that when you save money in the bank, your bank charges different rates of interest, then you have the lower lending rates. When you lend to the bank, you are being offered lower rate, but when you borrow from the bank, then they will give you at a higher rate. So, that we are not considering. That credit market imperfections we will be examining separately. There you will have the role of collateral, limited commitment, and then further the good borrower and the bad borrowers, the credit market asymmetry will try to solve. So, that part is different. Here for the time being, for the sake of simplicity, we are assuming that the R is same for borrowing and lending. Now, the first question is write the intertemporal budget constraint of the consumer, solve the consumer's problem and find an expression for the level of savings as a function of incomes and interest rate. Assume that there is a government that taxes interest income in period 2 at the rate. Write the intertemporal budget constraint. So, let us first solve this part. Write the intertemporal budget constraint of the consumer, solve the consumer's problem and find an expression for the level of savings as a function of incomes and the interest rate. So, this is how we are going to solve about it. So, if you try to solve, then it remains same, that C t plus S t is equal to Y t, right, and then we have the C t plus 1, then here you have the Y t plus 1, and then we have the S t 1 plus R t. If you try to solve for S t, substitute back into the original equation, you are going to get this expression. So, which is nothing but C t plus 1 upon 1 plus R t is equal to Y t plus Y t plus 1 upon 1 plus R t. To get the Euler condition, what we try to solve through constraint or unconstrained optimization. So, here we just solve for the C t plus 1, this is what we have solved in the previous. So, max C t is equal to U C t plus beta U c 1 plus R t Y t minus C t plus Y t plus 1. Here we have du upon d C t. So, here we have the marginal utility of C t minus beta u transpose 1 plus R t Y t minus C t plus Y t plus 1, and here it is multiplied by 1 plus R t. So, this part becomes the C t plus 1, and then you can solve for this. So, you get the Euler condition. So, Euler condition is what? Here you have the first marginal utility of current consumption is equivalent to the marginal utility of future consumption multiplied by beta times 1 plus R. So, this is how we get it. Now, once I have this, then what is the next part? Solve the consumer's problem and find an expression for the level of savings as a function of incomes and the interest rate. So, here we have to now find the level expression for savings. So, how do you find that? So, saving expressions are how. So, we have got this expression, now let us work it out. So, here it becomes. So, now if you think about, since I have assumed here log C, so Euler condition will be what? So, if I am going to get this expression, so here we have log C which means t plus 1. So, here we have the marginal utility of current consumption is equal to 1 upon C t, marginal utility of future consumption is equal to 1 plus C t plus 1. Now, substituting this in this particular expression, what is that? So, it becomes 1 upon C t is equal to beta into 1 plus R t 1 plus C t. So, here it becomes C t is equal to C t plus 1 upon beta multiplied by 1 plus R t. So, once I have this particular expression, that we get it. So, here we are, how we are driving this particular expression? Here we are just replacing the mu hat C t. So, which is 1 upon C t is equal to beta into 1 plus R t 1 upon C t. So, this is what we are going to solve. So, if we just solve for C t here, this is what we get the expression. So, C t is equal to C t plus 1 upon beta into 1 plus R t, and we know that the saving that we have. So, saving is what? Saving is S t is equal to Y t minus C t. So, I have the C t expression here, I just substituted. So, S t is equal to Y t minus C t. So, I just substitute it here. So, you get this expression. So, S t is equal to Y t minus C t plus 1 upon beta into 1 plus R, and if you solve further for this particular expression becomes the same. So, if you just C t plus 1, if you try to replace this by this expression, because we want to solve the income and interest rate, and in the current period only this particular expression has to be. So, we are going to replace this by this. So, here it will be S t is equal to y t minus 1 up plus r t y t minus C t plus y t plus 1 upon beta into 1 plus r t. So, this is how it looks like. So, here it means the saving expression finally it is nothing but y t minus 1 plus r t multiplied by y t minus C t plus y t plus 1 upon beta into 1 plus r t, which means that this expression that you have, it can be called as this as saving plus 1 plus r current period saving plus y t plus 1 upon beta into 1 plus r t. So, this is how we try to get it. So, finally, we have this expression. If we solve this further, you arrive at this conclusion. So, this is how the saving function can be derived. Now, further is the second part. Second part was that assume that there is a government that taxes interest income in period 2. So, once I am talking about interest income, then I am talking about the proportional tax in period 2. Write the intertemporal budget constraint of the consumer, solve the consumer's problem, and find an expression for the level of saving. So, how it works? It works here. So, C t plus 1 upon 1 plus R t 1 minus tau is equal to y t plus 1 upon 1 plus R t 1 minus tau. So, if you solve for C t plus 1, this is what we have, 1 plus R t 1 minus tau, y t minus C t plus y t plus 1. So, if you substitute this here, so here you have to always keep in mind that when I am talking about the interest income, so here it means that the tax is now imposed on the interest. So, here it is proportional tax 1 minus tau. So, this is what we get it, which means that du upon dct is equal to the first order condition, which is the marginal utility of current period consumption. Finally, in your Euler equation, what you are trying to get is this part. So, marginal utility of current period consumption is equal to beta times the future consumption, and then the multiplied by the rate of interest, and rate of interest is again subject to the taxation. So, this is what the change that you see from the previous Euler condition is this 1 minus tau, and this becomes an important topic. So, here what we see is that if you have the incidence of tax, then incidence of tax goes on the when we are talking about the proportional tax, which means that some percentage of income will be taxed. So, here in this case since we are having the interest income tax, so here it becomes R t 1 minus tau. So, this particular part it is important that you should understand these dynamics. So, we will continue in the next session from here. Thank you so much.